Welcome to a new test and teardown video. This time it's a Brüel and Kjær level recorder type 2305, and as you see, this is the B version because of the wooden case. This is actually mahogany as far as I know. And there's a really nice lid that comes with it. And the thing is, the lid comes, of course, from the top. And then it is locked 4 places to the unit. And then you carry it, you lift it in the lid. So that means you must really trust the locking mechanisms. Yeah, you can see this one is completely bent because it was unfortunately really badly thrown into the dumpster where it was saved. Yeah, I find it really hard to say this because I'm so sad about how people treat stuff they want to throw out instead of just calling some friends who can come and pick it up and be happy. There's a nasty dent here in the wood, and there's a foot that kind of crashed, see, due to the dumpster thrown out. But the rest looks kind of okay. I see some little kind of damage on the case, but other than that, it's okay. Yeah, the reason why I say you really need to trust those locking mechanisms, you can see this thin metal here that is carrying the entire weight. That is because this unit, including the case, weighs 28.3 kilos. It is very heavy. And there are many reasons for this one to be that heavy, and I look so forward to show you all the things. This one is the tube version. It is from 1965. So it's full of tubes. We got 10 tubes inside. And the motor drive is absolutely fantastic. The entire motor drive is made with a lot of gears. We got spur gears, changeable gears, worm gears, all sorts of things. It's very complex motor and gear drive system. And this is carefully explained in the manual. I was able to find manual and schematics and everything at peel.dk. This is where I always find these things, especially when it is a Danish product like this one. We got a few problems with this mechanically. I need to inspect the entire paper stuff here because nothing is moving and it looks like it's completely stuck. We got paper jammed as well. But due to the thrown out kind of damage, I don't dare to power it up first, but I definitely need to open and inspect. So this is the bottom side, and I think the whole unit is just mounted using the 4 feet screws. And see, this one is completely loose. This can't be good. I got some sticky capacitor leak right here. Or is it just oil? I will have to inspect that. And the screw here is broken. And that is the nasty. Yeah, it's also bent a little bit. Yes, so that was real easy. It is definitely the 4 feet screws. Just wanted to show you this absolutely nice wooden case. And I find some little handwritten notes. I believe this is 18, and then the other one there's 5. And there's also 18 here. So that's that's funny. I do find all these handwritten notes a lot in old equipment, actually. I always find it quite funny. So here is one of the feet. And then of course I just 3D designed a new one. It takes only a few minutes to do this. So now I can go and start a 3D printer while I go and play along with the unit. So now I am inside this unit and I'm starting to look a little bit deeper into all the funny details. I'm also done with my little 3D printing a new foot, and I think it's very, very similar in shape and size. I was a little bit afraid if it's not exactly the same height, then it's gonna rock a little bit. Otherwise, I just print two of them, so they will be exactly the same size. And there's another little funny thing what I did. The screw was broken here, so I just took an old brass screw and just soldered to the broken piece. Look at that. Because the broken screw was also a brass screw. So now it's easy to get out. I tried to poke it with screwdrivers and stuff and I couldn't get it out. That was a super easy trick. So let's look a little bit on the internal parts. I should maybe post a block diagram of the unit. This way you can see what we got. So on the block diagram, first we got an input potentiometer, an input attenuator, and then we go to the range potentiometer. And then we go to a mechanical chopper. Okay, so that will be the first four parts that we look at. And then we're gonna go back to the unit here. So up here we got the input potentiometer, input attenuator. There's also a little switch. And this switch gives a known reference voltage into the input. This way that you know that it's measuring the correct signal level. And then input goes to the range potentiometer. That is a very, very big potentiometer that's sitting up here. I'm gonna go and take this out and show you what this is all about. The range potentiometer is also connected mechanically to the writing device that holds the pen. And this is actually our position feedback. Then we have the mechanical chopper, and it is that unit. It is, funny enough, not mounted straight. But in here there's a little, you could call this a vibrator, but vibrators, they are self-resonant. This one is just like a relay, and it is controlled by mains frequency drive, but it is specially made so that each contact set is in perfect balance, so that it creates a perfect switched waveform. That is the idea about this unit. And then all the signals goes to all the tubes and stuff. When you have an AC signal instead of a DC signal, and this is what the AC chopper is doing, right? Now you can amplify using tube technology, because now it's an AC signals. AC signals, they can be made in tube amplifiers, so that the tube parameters don't really affect the amplification level, and you can also feedback an AC signal into a multi-stage system, and it's much more easy to handle. And definitely this is what you need to do to have an accurate no drift solution. If we look a little bit back in the block diagram, I can show you the magnetic drive system. So this is a linear drive that drives the pen, and that magnetic drive system is this big thing up here. Let me show you how huge this is. So in here we got magnets and iron and windings, and that is driving. There's a long little, I think we can, yes, we can see it here. So this little thin stick, or this little rod that goes out of this, right? This goes all the way to the pen drive. it is of course made so thin, so the mass, the weight of this part that moves is as low as possible. In this way it can move back and forward fast. Also, what we have seen in the block diagram is all this mechanical drive, and the motor is a synchronous motor. There's a capacitor, I believe it is that one up here, and this capacitor makes it go forward or reverse depending on how this capacitor is connected to the motor. This motor is, by the way, a Pabst motor from Germany. And then we have all the gearboxes. Look at all that gearbox, fantastic. And we got more gears out here, and it's, yeah, full of all sorts of, this will be the knobs that changes, that moves this entire sledge back and forward. So you have an output coupling drive. I should of course show you a few pictures from the manual so you can see all the fantastic mechanical details about all this motor drive and what not. I mean, this is amazing. And this is of course why it is so heavy. It's full of brass gears and fantastic things. And on top of all this, in here, I don't know if you can see that, but there is a very big mains transformer. We also have here on the right side of the unit, let me swap it like this. There will be output drives to different external plotters or recorders or something else. And we got remote control and a second channel input here, so you can synchronize more of these if you want more channels. They thought about everything. Also, I like to show you another thing, why this thing is so heavy. I don't know if I can show this, but the entire top frame or top part, yeah, look in the upper left, or I don't know, how can I show you guys this? It is made in one big solid aluminium casting. I don't know how to show this. Yes, here it is a little bit visible. Can you see it when I move around with the light? No, you cannot see anything. Yes, here we go. Terrible. There's only this tiny little gap here to video stuff. But what I can do is I can take away the rear cover here so we can look in a little bit better. Also, when you look at the circuit board, it's full of holes, and that is of course for thermal. So it's a very good thermal design. And the bottom plate here was of course full of holes. And remember, the feet, they are this tall, so it will suck through a lot of air and this way not melt down. Because it's using, I think it's 110 watts in standby and 145 watts when the motor and all the gearbox stuff is running. From all my investigations, I believe that all this oil here is what we have seen on the bottom plate, so I don't have any big reason to be super afraid of anything. I also verified the capacitors here, and they look nice and fine, except for this one. I don't know how you can see this drop problem here, but what I've done is, this is completely dried. I took my ohm meter and verified this stuff is non-conductive. So that means this capacitor could be perfectly fine. This must be a dried oil spill or something, or glue. Here is the logarithmic potentiometer, and this is directly connected to the moving pen. The reason why you can change this is, of course, if you want the unit not to be logarithmic, or it could be, or the dB ranges and stuff like that. So this is a classic way that Brüel and Kjær, they made it. In many of their plotters, you can change the potentiometers. And this is of course also possible in this unit. Look at the size of this thing. I would imagine this one is like an interchangeable part, right? What is the cost of this? Maybe we should have a little look. See, here is all the contact points, probably to some windings of some resistor elements. It says also something about how you should mount this. You shouldn't mount it if it is out here, but it is luckily in all the way in, so it is legal for us to do all that. Here's the contact system. This is just amazing. Yeah, let's look inside that one. I am inside the logarithmic potentiometer, and I mean, all respect and good things to these guys who made this unit. When I was looking at it from the outside, I could only see all these contact points here, and as you can see, there are quite a lot of contact points, and the distance between them is just amazingly tiny, short, right? But this is actually contacts. And they soldered by hand all these many wires. And it goes to all those circuit boards with all the resistors. And there you have it, your logarithmic potentiometer. And frequency compensation, capacitors and whatnot. I could really love to be in that room the day the designers came up with the idea for this one, right? Hey, let's try to make something that will cost 1 million hours to manufacture by hand. Yeah, I love to hear those discussions and arguments about this. But it is also the heart and the brain and everything of this entire unit. Because if this is not done perfect, you need the logarithmic response here to be absolutely perfect. Remember, this one is directly connected to the printing device here, right? And that makes up for exactly your readout accuracy and all those things. So this is probably the way that they came up with. I have seen later devices, not exactly this plotter, but later devices where they did the logarithmic in a thick film laser adjusted resistor system. So that is probably a lot cheaper to manufacture compared to all this. Wow, I am completely blown away. I did not see this coming. I hope you got the same kind of feeling that we just find these crazy things, and now we can document this and enjoy it. I've been trying to figure out about this little part here, how to mount this, because on all the pictures I can find in the manuals, I don't see this part. So it's either down here or down here, right? Because I can't see it from the top. And then you push to release. This holds the paper reel, but this is something I will figure out. And then there's this little funny thing here. It seems like all you have to do is just press it in like this, and then it holds this whole mechanism just a little bit up. so the paper can go under here, right? And here is the little wheel that grabs into the paper. There's also a nice little lamp here that shines light down here so you can see what you're doing. I kind of like that. And they also explain in the manual about the writing pens. We got a few different types, and this seems like you press them in here. Some they are like really tiny and have just a tiny little needle filled with ink, and you can refill and re-clean and all these things. I just don't have these, so I will figure out something else. And then there is this little magic. So there's the event marker is also a little writing pen you put into this little hole here. So imagine you have a tiny little ink filled pen down here outside of the normal chart, and it's pointing exactly at the same position on the paper and where the pen is writing as well, right? So when you hit the event marking button on the unit, this one goes click clack and make a little dot. It could of course be in another color if you like. And now you know exactly what happened. The event marking can also be done on using the remote control input, so it could be an electrical pulse from something that stimulates this indication. Let's look on the paper here. As you see, we got different dB ranges. So this is the 50 dB. It could also be any other dBs depending on the logarithmic potentiometer you have installed. My unit got the 50 dB one, so it covers quite a wide range. And then you can write all sorts of stuff down here. Settings, rectifier, frequency limits, writing speed, paper speed, all those things. I kind of like that. I got a very big reel of paper here, so that is also good. I don't know if it's possible to buy this paper. So this is a, what do you call this? A normal chart, I guess. Normal paper like that. This is what you would normally expect, right? But this unit can also write on round paper. So if you put in a round paper for polar plots or antenna direction plots or whatever, then you stick in a little holder in this hole here. That is the center of your round chart. And then all the way around the round chart, you got the same little holes in the paper that grabs here, and then it just works as well when it's round. I really like that. Okay, it all made sense. It was not that easy to lift this and push in the paper and all that, but I kind of figured it out. The reel needs to go all the way to the left, and then this paper holder here also needs to push the reel all the way to the left. And now look at that part down here. It all makes sense. It has to be that way. There is no other way it would make any sense. I also figured out this little here. If you dial this, you can lift up your plotting pen, so you're not making any marks on your paper when you're ready to set everything up. I removed the rear plate so we can have a nice look inside, and yeah, that is one big hefty mains transformer. We can also see the 10 tubes that's doing all the fantastic things in here. And it's also easier to see the chassis is one solid aluminium casting, like you see down there, right? I like the way that they mounted circuit boards with resistors and capacitors and all this for all the different settings. This makes it a lot easier to avoid all sorts of mounting problems. And look at this one, the shaft goes all the way in here, and then we got the rest of all the goodies. But I am done inspecting everything, and I think it's all pretty fine for powering up. So let's try and power it up. For the very first time, motor is off, power is on, paper drive is stop, forward, and then all I should do is crank on my external mains slowly up, and let's monitor. Click. That is all good. 85 watts. And it's warming up. And I got light in this beautiful pilot lamp. I can hear there's a 5 kilohertz tone. I think that tone is the linear motor drive that runs at that frequency, but I should be able to play with the DC response. Range potentiometer is 50. Writing speed should be input attenuator. Oh, I forgot to input some. That is 1 hertz of input. Then I should be able to see something, right? I should see this move. Ah, paper drive. Motor on. Yes, paper drive. So that goes. When you want to change the paper speed, you pull and then you see? It goes fast. So all that is good. Drive shaft. And you can change all this. So that should be good. Let's see if this little indicator here is working. That is the event marking. No, I don't see anything moving here. But probably I am not in some sort of a, I don't know. Why don't I have any movement? Stand by. What am I doing wrong here? That's boring. That's really disappointing. Of course it doesn't work, but I can hear something in the drive. Can you hear it? It's actually trying to move. And when I change the different settings here, I can hear. Yeah. I can hear that the linear motor is really trying to do some stuff here, but it's just not coming out. So there's a DC or there's some sort of a control that's just hammering it all the way to one end. So I think I will just turn it off. Look at that. I got it up and running. So it was a mechanical issue. So I had to massage all this and oil it and clean it a few times. And now this is a sine wave input at 0.1 hertz, and as you can see, this is of course a logarithmic readout, right? So it's not looking like a sine wave, and also it's a little bit stuck, and the feedback loop is having a little bit of problems to compensate its positions. And you also see, oh, let me turn this off, then you can better see what's going on. The little string wire pulley thing here, that is a 2-to-1 gear ratio. See what's going on here? That shaft here goes directly into the linear motor, And that's of course what's driving everything, right? And this stick also goes to the logarithmic potentiometer. But of course we want to have a 100 millimeter readout here on the paper, and this is why they have this gear system made up here. So that's what there is about all this. But of course we got a few moving parts that is touching metal here, and a little bit of corrosion, and probably this also was bent a little bit when this one was thrown out. So it's not moving super smooth. So I'm just trying to massage it some more and give it a little bit of cleaning again. Probably I will be able to get it up and running. There's a nice little shield or a cover. And there's a little screw here that's holding the cover. But it's not only that. This is also the mechanical calibration, as you see here. See? This moves the readout. Isn't that cute? So they really thought about everything in this unit. I didn't really plan to show you so much more or say so much more. I just wanted to one last time pop in the block diagram, and then you can go back and forward in the video, and this way you can see the different sections in the block diagram. And then I will show you the schematic diagram with all the tubes, amplifiers, and the feedback loops, because everything in the schematic is really drawn almost like it is in the block diagram. And I kind of like that. So it's very, very easy to figure your way around a schematic that is drawn very similar to the block diagram. So the good old guys at the Brüel and Kjær really did a good job into the documentation and to try and explain everything, so you can easily see what is doing what. So that is all I wanted to say. Thank you very much for watching. Bye bye.